Okay, so we've got everything plugged in. Sorry, this setup is kind of just rushed together. This is my first video. Um, just making sure everything looks good. The power supply is on, and see, this turns on, and we have lights. Okay, so power supply works good. Now for the graphics card. Okay, motherboard's lining up, everything works. That. Okay, now for we have the fan spinning for the GPU, and that is not unexpected. I want to share a workstation I built for someone a few months back. The PC I was building for this particular person would be used for 3D animation. The following diagram is the list of parts in both Canadian and US dollars during the months of March, but prices have tempered significantly since then. They had a budget of $1,500 and wanted the PC to be able to run programs like Maya, Blender, Unreal Engine, ZBrush for their 3D animation program they were taking in school. You can get significantly more with a budget of this size, but now on September 15th of recording the audio, you can probably get the parts for around 900 Canadian or 700 US used to around 1200 Canadian or 1100 US with newer parts. But that's an estimate from what I've seen on the local secondhand market and online. No guarantees and no promises. Or if you do decide to buy a pre-built PC, you can get one for $1,500 before tax, with the only drawback of not being able to pick your parts. The first PC from Canada Computers has an i7 12700F processor, and the PC is a really good deal in my opinion when it comes to price to performance. Of course, it's priced in Canadian dollars. The second computer from Memory Express has less RAM, but is also a great choice and again, priced in Canadian. And the last one is from Micro Center. Though I couldn't find what the memory size of the GPU was, the PC is priced in US dollars. For the motherboard, I went with the Asus Prime B550M-A Wi-Fi 2. I was able to get it for a decent price with 4 channels of up to 128GB of potential RAM, 2 M.2 slots, one of them allowing support of PCIe 4 SSDs, 4 SATA 6GB per second ports, and integrated 6 Wi-Fi and Bluetooth. It was the best motherboard available at that price range. For the hard drive, I purchased a Western Digital Blue 1TB SN570 NVMe SSD for its decent performance, read and writes for an affordable price. It is a Gen 3 drive, and we are at Gen 5, but it is sufficiently fast. The motherboard is capable of up to Gen 4 drives, which in this case the slot can be saved for a Gen 4 SSD for a future upgrade. You will need more storage space in the future, as it is a guarantee for this kind of work, but for more storage space for projects, you can always buy a SATA SSD or even a hard disk drive, which you can get much more space for less. Yes, it runs slower than an SSD, but there are some great options for hard disk drives, which I may post in a later video. Something I noticed helping others with their PCs for animation and graphical design is the high CPU usage and significant memory required working with large projects. So for the build, I purchased an AMD Ryzen 7 5700X 3.4 GHz 8-core processor, and I paired it with the Corsair's Vengeance 32GB dual 3200 MHz with a cast latency of 16. If you do not understand what anything I'm saying means, do not worry, there are channels out there that explain them, as well as I can cover them in a later video if you would like. I should also note that I went with 32GB of RAM to start, but you will probably need more for larger project sizes. The motherboard has 4 channels, so you could always buy 2 more sticks of the same type or sell your current RAM and buy a larger set of RAM. Individuals I've worked with have told me that their first year in their programs, 16GB was sufficient, but they ran into problems when saving larger files down the road. Problems like the application just closing and all the work not being saved. Another problem was the length of time saving projects. Having more cores in a processor speeds up this process by allowing more work to be done when your PC is performing a task. One could have argued why not sacrifice an extra CPU and RAM performance and go for a better GPU, and that is a viable option, but I considered other factors. 1. The GPU market is absolutely terrible, and upgrading in the future would be a smarter option. 2. The software programs were intended to be run with NVIDIA GPUs and are more optimized for such. 3rd, VRAM. Higher tiers of NVIDIA GPUs had less VRAM, and even though they are faster, when running large projects, a lot of VRAM is required, and like stated before, I thought it would be better to get something that costs less for a budget build with plenty of VRAM, and that does sufficiently a decent job, allowing one to upgrade in the future when the prices are significantly cheaper, only requiring the GPU to be upgraded instead of the RAM, CPU, and GPU. This gives more time before the need for an upgrade. Having insufficient VRAM will cause the GPU to draw from regular memory, slowing down further the performance of the GPU and taking up RAM space. More cores also means less stuttering when actually using the applications and avoids the problem that they were running into. And the small amount of money saved from the CPU and RAM would barely get the GPU up a tier without sacrificing significant performance. And one may also argue that prices for 4000 series GPU are significantly higher, but as time has progressed, the GPUs have come down in price and should continue as time goes on, as newer hardware are released and demand continues to fall. As it stands now though, the prices are still a little high, but they're getting there. But back to the build, it is for this reason I've gone for the EVGA 12GB overclockable NVIDIA GPU, which I was able to grab at the time for $380 Canadian. I recently saw some going for $300 on the secondhand used market. I understand that EVGA has currently discontinued producing GPUs for now, but their 3060 was one of the best in the market for that series. I would also like to just let you know that if you weren't already aware of 8GB 3060 series in the market, which have shown to be of lesser quality and one should avoid. For the cooler, I did not go with the stock fan that came with the CPU. Instead, to get the most out of the processor, I went with a Deepcool Gamex GT ARGB cooler. I mean, you can go with the stock fan, and you can also get a tower cooler for dirt cheap used, but the person that asked me to build the PC wanted it to match the rest of the tower. So, oh well. If it looks great, then it will give the illusion it performs much better, even if you know that the looks don't matter. For the power supply, I was able to get an EVGA Supernova G3 750 watt power supply for $50 used. For the operating system, that is up to the individual's preference, but listed is Windows 11 since that is the most widely used operating system. And lastly, the case is a Deepcool Matrix 50 ADD RGB 4 fan ATX mid-tower case. The individual did not want a screen/grid in the front for a smooth look and quote-unquote easy cleaning, at least for the surface. But, I mean, with all PCs, they will come with screens and grids that you'll have to clean every once in a while. That is just something that is unavoidable. Some things to note when building your PC, or at least from my experience, is that you will sometimes have some of your own troubleshooting to do. If you're lucky, there won't be any problems, but for this build and some others, I noticed when first booting your PC, the monitor will display some tearings when using a display cable. To solve this, just use an HDMI cable and then switch after updating the drivers. All you really need to do in the BIOS is overclock the RAM, which is really simple, just a few clicks. For this motherboard, the Wi-Fi did not work until after updating the drivers. I solved this by using a USB Wi-Fi adapter or dongle, but if you do not have one, you could try an Ethernet cable. If you don't have either, you can download the driver updates onto a USB from another computer and then plug it into your new PC and update the drivers that way. Lastly, one of the PC cords for the case had a manufacturing defect in which one of the holes had plastic covering, so I had to get a needle to open it up. Other than that, not really a big deal. The case fans also don't make cable management easy no matter what I did. Hopefully no one else has to ever work on this PC I built. And the Deepcool thermal paste was a little runny, but works fine, no problem. Of course, building one's own PC will always be better than purchasing one from a big box. since building one will always be much cheaper and allow one to customize a PC to their needs. And as long as you know what you're doing, getting quality parts is assured. I could only find some parts used for a decent deal due to time constraints, but I have no doubt you can buy all parts used for significantly cheaper, allowing you to upgrade some parts to something better. Also note the PC should also have no problem running modern games, but it is not optimized for such, as getting a better graphics card and going for 16GB of RAM and a 6-core CPU would be the way to go. I'm certain if you buy used parts, you can upgrade to a 3080 or better of a GPU, especially at the present moment with DDR5 and the new GPUs out in the market with everyone upgrading. Just be aware of the risks of buying used parts. Thank you for watching till the end. Let me know if you would have gone for something else. I'm also working on finishing another video of a build I did for someone where I set a goal of not only trying to purchase all the latest parts, but get them on the used market for a discount. So if this sounds like something you would be interested in, please subscribe, and a like is always appreciated. Thank you very much. Something I noticed helping others with their PCs for animation and graphical design is the high CPU usage and significant memory required working with large projects. Oh, I just noticed something. The dB is too high.